Hey guys, it's Mr. Zimmerman, and today we're going to look at Formative 2, and we're going to highlight some of the key concepts that you should be walking away from this benchmark task with. Let's go ahead and dive on in. All right, so we're talking about exponential and logarithmic functions, and essentially standard 3.1 and 1.2 are asking, hey, can you use a graph? And then 1.2 is asking, can you give me specific answers using that data? So a local high school student population is modeled using this function 1500 times 1.05. This is going to be what's graphed below. And X represents the time in years since 2010. So essentially, to make this a little easier, instead of putting 2015, they're just going to use X as 5. Likewise, 2020, it's going to actually be 2030. So let's continue. What is the student population in 2010? Okay, well, 2010, how many years have passed since 2010? Well, that's going to be 0 years. I'm going to be looking for the initial value, which is also going to be the y-intercept. And this is going to be 0, comma 15. And we want the 1500 part. That's how many students are going to be attending. In what year is the student population expected to be 4,000? Okay, well, 4,000 students. I'm going to start at my 4,000. And where does it intersect? Now I'm going to follow my line to see the x value. Okay, in 20 years since 2010, it will be 4,000 students. So I'm going to go ahead and use 2030. Is this a function, an example of a growth or decay? And explain your answer. Well, from the graph, I know it's going to be a growth. The graph resembles a exponential. I'm looking at part C for spelling in case some of you guys aren't as confident. Growth. The graph resembles an exponential growth function. Now, this is a little weak because you might be like, well, what if I'm accidentally looking at it wrong? The kicker of this is going to be right here, 1.05. Since 1.05 is greater than 1, it must be a growth. All right, let's go ahead and jump down to the second part. So basically this problem, Nicole and Tadic are both investing $500 and they're going to go to different banks. And basically you're going to have to determine who has more money after 10 years. That's just a quick summary of this problem. You might have to read it a couple of times. So Bank A and Bank B. And we need to figure out who gets the better bang of their buck. So Bank A is offering, let's see, continuously compounding interest. I know that's going to have E. Oh, wait, it did have E. I'm great at this. B of X is going to be equal to 500 E to the 0.03x. And notice how 500 is the starting amount times E to the percent of time. This is the standard form for a continuously compounding interest. Now, I need to plug it in for 10 years. So I'm going to go ahead and plug in B of 10 is going to be equal to 500 E to the 0.03 times 10. And I can actually simplify this before I plug it into a calculator because knowing how decimals work, when you multiply by 10, I'm going to just move it over once. So it's going to be 0.3. This isn't necessarily necessary, but it helps you just be cleaner about it. So I'm going to go ahead and plug in 500 times E to the 0.3 power. And I'm going to go ahead and get 674. Now I do have to round it because it's money, so it's going to be 93 cents. Now Bank B is going to be 10 years. How much money is it going to be? 671.96. So which bank gives you a better bang for your buck?